Recording in progress.
Whoa, that's loud. All right. Okay. So if you have a polynomial, what was that? Sorry? It is. Doesn't it look better? Really? It's way brighter. Yeah. Okay. So say you have a new polynomial. We have a new projector. Sorry, mixing my words. Say you have a polynomial function that looks like that. I mean, look kind of weird, right? X to the n's your degree, a sub n's a coefficient of it, and you go in descending order until you get down to the constant. And they don't necessarily have to have integer coefficients, but we'll say we do. Every rational zero will take on this form. And remember, rational numbers are a ratio of two integers. P and Q are integers. Now, P is going to be all the factors of a sub 0, which is your constant. Q is going to be all the factors of a sub n, which is your leading coefficient. Okay. And so you do P over Q to find all the possible. So P over Q represents all possible rational zeros. So you guys see M4? Yeah. Okay. So let's put this in practice on the examples. Can we move forward? We're good? All right. So for example 12, list all possible rational roots. So your P is going to be all the factors of 1. And Q will be the same thing, all factors of 1 still. Actually, that's just, sorry, let me just type that up. That's just really messy. So P equals okay. So when you do P over Q, I mean, what are the factors of 1? Obviously 1 and negative 1, right? And likewise here. Right? So there you go. So we're gonna do a little bit of trial and error. So I'm gonna use synthetic division just because just seems a little easier. And I'm looking for 0 as my remainder if it's gonna be a factor. Because part of the factor theorem. 1, 1, 1, 1, 2, 2, 3. So no good. Let's try negative 1. 1, negative 1, negative 1, 1. Okay. So this has no rational roots. And that could happen. That's totally possible. That totally could happen. So even though you had 2 possibilities, I emphasize the word possibilities. It may not be possible. And how can you verify that? If you go to Desmos and type in the equation, y equals x raised to the 3rd power plus x plus 1. If I clear screen, that does not look like a rational number to me. Negative 0.6823. That's some. Yeah, exactly. And also, this crosses the x-axis once. It's a degree 3, but crosses the x-axis once. So where are my other 2 x-intercepts? Or what's going on with them? Or what are my other 2 zeros? What was that, Sean? They're going to be complex, exactly. Because remember, complex zeros occur in pairs. I'm not sure if you guys saw that in Mr. Band's class last year, but I still need to talk about polynomial functions with them. But Yeah. If you have all real coefficients, then your complex zeros happen in pairs. So anyway, that's what's happening with that one. So yeah, even though we tried it, none of them worked. Okay, let's try this again. For example, 13. Okay, here we're gonna have more possibilities. So I'll kind of go straight to the P and Q part. So P is all the factors of the constant. What's my constant here? So I'm gonna write all the factors of it. And you gotta put positive, negative. What's my leading coefficient? 1. So if I divide all those by 1, you basically get the same thing, right? Okay. So now it says use your calculator to help you determine possible rational root, then use it like blah blah blah. Now, Kieran, you're saying you did this like 17 times one time or something. I remember that. Okay. Will I make you do this by trial and error? Like, no. Because what if the answer were -6? And you start over here, and you test this 8 times. That's totally lame. I don't like that.
Mr. Bandman.
Mr. Man and I love to talk. Love to chat. So, um, and there's a possibility none of these could work. That's very, very possible. Okay. So here's what we'll do, guys. Okay, good. So I see you guys were traumatized by it. Won't relive that trauma. Don't worry. Okay, it's okay. I have a little more empathy. No, Mr. Man's cool. No, so let's graph it first. Okay. Hold on. Let's see here. So x4. So this is what you'd have. You'd have a graphing calculator. Now, what I would wind up doing is I'd probably give you some complex zeros and want you to solve them. That's what I probably wind up doing. Or something that's irrational, ask for exact answer. So I probably want you to do quad form or something like that. So, okay, eyeballing it looks like -1's going to work, right? And maybe 2. Okay. So let's go back here. Okay. So let's do -1. Now, if you skip any terms, you got to put 0 as a placeholder, just so you know. Okay, kickstart, bring the 1 down. -1, -2, 2, 3. It should work if you do it right. Okay. So what do you got? X cubed. Okay. So what you're doing is you're breaking down the polynomial. Okay. So we saw -1 worked in the calculator. You know, I mean, we didn't test it. You know, we didn't like look close in the calculator, but it's supposed to be good enough. You know. Now, should I do some things again, or can I factor a different way? How about factor groupings? Yeah. Why
Oh,
not?
but you can take out x squared and x minus 2 for that.
Yeah. See. You guys seen this before? I think it's easier. Because I saw 2 as another x-intercept, right? Okay, good. I'm glad you agree, Thomas. All right. So you have x squared plus 3 and x minus 2. So what are my other zeros of the function? So my zeros are going to be -1, 2. Now, even though they only ask for rational zeros, I'm just going to find the other 2. It's going to be plus or minus I root 3. That's going to be stuff we'll talk about next week. But you see why plus minus I root 3 will also be 0? If you set that equals 0 and solve x squared equals -3 square root, you get plus or minus I root 3. You're square rooting a negative number. Okay. Cool. All's good. All right. Okay. Okay. Let's keep moving. And actually, this will be our last example because I'll start this next week. So again, very short lesson. We do a homework quiz, and then you can do homework today. So hopefully, I have no homework over the weekend, so you can enjoy a long weekend. All right. Let's work this out. All right. If you want to use a box method, you can. I think synthetic just might be faster in this case. Now, I'm feeling a little ambitious. I'm going to do a little trial and error. Why not? Let's just try a little trial and error. Give me a possible rational zero for this one. One. Okay, let's try one. 3/2 would be another, or 1/2. But let's see if one works. Today is my lucky day. Look at that. I got lucky. There we go. Okay. Nice. Granted, I'll let you have a graphic calculator. I'll give you one of the zeros. Okay. I'm not going to make you do guess and check. Okay. And to be honest, you don't do this in calculus. So that's just stupid. I don't want you to do guess and check. But what this enables you to do is find other x-intercepts. If I ask you to graph it, you have the other x-intercepts, and you can do the graph. And there you go. So those are my zeros. Questions? By the way, when you're doing this, what was that? Yeah, I already circled the one. I'll put it right there. It's fine. Now, just another thing to keep in mind too, like what if I gave you a degree 4, degree 5, and I give you one of the x-intercepts? That's great, but can these x-intercepts repeat? They can't. If it bounces, yeah, of course. So sometimes when you do this process, you might have to test them. Like if I were to give you an equation and one of the x-intercepts, let's say one of the x-intercepts I gave you bounced, or we'll just say I just gave you an equation we had a graphic calculator. So you graph it, you see what happens, you see it crosses. What if it bounces in one of those places? Then that x-intercept happens twice, so it has to do some division again with that. And make sure I keep that in mind. So it's just something to think about. So I think that's as far as I want to get because the homework doesn't covers up to that. So next week we'll do pages 13 through 16. So actually next week is back to 75-minute classes because of 4-day week. I know. So we'll have a lesson on this. We'll have a lesson on rational functions. Then we're going to review for our test next week. So on I think our test is on the 30th. Yeah, I think it's on the 30th. Yep. So we'll have a couple days for review as well, the last week of January. So, okay. All's good? All right. So let me give you guys a homework quiz. I'll stop the recording.
Yes.